Welcome everyone to this discussion on the chapter of laws of motion. We were doing the topic of friction, and in particular, we we were dealing with problems of static friction. So let us continue and jump right back into the problem. So we have a block. It is of negligible mass. That block is being pushed by force F at an angle alpha with the horizontal as shown in the figure. If the block is pushed at an angle greater than angle theta, then the block stays at rest. True or false? What we want to do is that we want to, number one, relate it with a situation which we usually encounter in real life. That if there is a heavy object which is kept on the floor, then if we are supposed to move it, then if we want to move that block in some direction, we want to pull that block or give some motion to it, so it say that it is easier to pull that block, right? And even if we don't want to pull that block, we want to push it, we would try to use a smaller angle to push that block, right? And by angle we mean this particular angle alpha. So that is what this question is asking actually. If the block is pushed at an angle greater than this angle, greater than angle theta, where theta is given to us, then the block won't move at all. So let us draw the figure. So you have a block, and block is kept on a surface, and some force F is acting on the block at some angle alpha. If we draw the gravitational force acting on the block, then that would be 0, since the block is of negligible mass. If we are going to draw the forces on the block, then the force F would act in this direction at an angle alpha with the horizontal. There would be some normal force, gravitational force would be 0, and the force of friction would be acting along the surface, trying to prevent the motion of the block. So we know that for the system to stay at rest, the forward force acting on the block, that is F cos alpha, that is the component of the force acting in horizontal direction, should be balanced by the force of friction acting on it. The normal force acting on the block would be balanced by F sin alpha, and we said that we'd say that the maximum value of friction which is available for us should be equal to mu times n, that is coefficient of friction into normal reaction. So this would give us the value mu into F sin alpha. So this is the value of maximum value of friction. So let's say that the force of friction acting on the block, that is mu F sin alpha. This force of friction, this is the maximum value of friction that is available to us. So if this value of friction is greater than the force which is trying to get the block moving in forward direction, then that force should be more than the force of friction available to us for the block to stay at rest. So we said that this condition has to be followed. So we would say that mu should be greater than cot alpha, and we are given that the value of mu is cot theta. So it's a cot theta has to be greater than cot alpha. So theta should be less than alpha. That is, we should apply the force at an angle greater than this particular given angle theta for the block to stay at rest. So this is what is given to us in the question, that if the block is posed at an angle greater than theta, then the block stays at rest. So we have proved just that. So this statement would be correct. So for alpha greater than theta, the block would stay at rest. Next question. So we have a mass of 20 kg, and that mass is kept on a surface which is having a coefficient of friction mu equal to some value which is given to us. It is 0.25. The coefficient of friction is some 0.25, and it is given that the block is sliding over the floor due to a force F. The block is already sliding on the floor. This is given to us. The first part asks us that, for this particular example, asks us that what is the force of friction acting on the block. So as the block is already moving on the surface, we would say that kinetic friction is acting on the block, and the value of kinetic friction, we already know that value is given by mu k into normal reaction, when mu k is coefficient of kinetic friction. Coefficient of kinetic friction is 0.25, which can be written by 1 by 4. The normal reaction of the block can be written as mass into action with gravity, which is given as 9.8. So this value would come out to be some 49 newtons. So this is the first part of this example. The next question, question number 3, it is asking us that in the previous example, find the acceleration of the block if F is equal to 99 newton. So the force applied on the block is some value that is 99 newton. Then the force of friction is going to oppose it. There is going to be some normal reaction and going to be some gravitational force acting on the block weight. So it's a sum of forces acting in x direction, that is 99 newtons, minus the force of kinetic friction is equal to mass times acceleration. So the force of kinetic friction is equal to 49 newtons, which we have calculated already. It won't depend upon the force which we are applying on the block. This force can be how high and can be how low. As long as the block is moving, the force of kinetic friction is going to be mu kn, which is 49 newton, is equal to mass of the block, which is 20 times acceleration of the block. So this would give us the value of acceleration as 50 divided by 20, that is 2.5 meter per second square. So let us move on to the next question. In the next particular question, a block of mass m is kept on the surface of coefficient of friction 0.2. A force F equal to 10 Newton is acting on the block, and now we are going to pull the block instead of pushing that block. So the force is acting at an angle theta, and this is the mass of the block. The coefficient of friction is some value mu k, and the action of gravity is some 10 meter per second square. The mass of the block is some 1 kg. So we are supposed to find the acceleration of the block for different values of theta, and root 3 is given to us. So let us begin. So let us draw the diagram of the block first. So the block is having a mass m, and a force F is acting on it. Some gravitational force acting on the block of mass of value mg, a normal reaction, and the force of friction which is trying to prevent the motion of the block. So the force that is 10 Newton is acting at an angle theta to the horizontal, and if we are to take the components of F in the vertical direction, that component would be F sine theta. So we'd say the upward force is acting on the block, that is normal reaction, and F sine theta would be balanced by the gravitational force, that is mg. So we'd say that normal reaction is equal to mg minus F sine theta. So we'd say the horizontal force acting on the block is equal to F cos theta minus the force of friction F. So let us assume that the block is moving in horizontal direction with an acceleration a, and by taking that assumption we are assuming that the force of friction, the force acting on the block in a horizontal direction, is able to overcome the frictional force F. So the net force acting on the block in a horizontal direction is equal to ma. Further, we will say that F cos theta minus the force of friction, which is equal to mu times the normal reaction acting on the block, that is mg minus F sine theta, should give us the mass times action of the block. So this gives us the calculation that F cos theta plus mu F sine theta minus mu mg is equal to mass times acceleration, which in turn gives us F is equal to cos theta plus mu sine theta divided by the mass minus mu g should give us the acceleration. Now here if the value of acceleration is coming out to be positive, then we would say that our assumption is correct, and if if the value of acceleration is coming out to be negative, then that means that our assumption that F cos theta will be able to overcome the force of friction on the block, that would be incorrect, and its value would come out to be some negative value, some absurd value would come out, which would make it seem that the force of friction is driving the block actually, but the acceleration in that case would be simply 0. So let's say that the angle at which we are trying to test our formula first is the angle 30 degree at theta equal to 30 degree. So at this particular angle, the acceleration of the block is coming out to be some force acting on the block, which is 10. So 10 Newton force, mass of the block is some 1 kg, cos 30 degree, that is square root 3 by 2, plus mu, that is 0.2, sine 30 degree, that is half, minus mu into g, where mu is 0.2 and g is 10. So this would come out to be some 2 value. So acceleration would come out to be some 5 into square root 3, which is 1.73 into 0.2 minus 2. So this value would come out to be some acceleration is equal to 5 into 1.93 minus 2. So this value would come out to be some 9.65 minus 2 meter per second square. So that would come out to be 7.65 meter per second square. So this angle, the angle which the acceleration of the block now the angle which we are changing it to is 60 degree. So let us see what is the value of acceleration now. So acceleration would now come out to be some value 10 into cos 60 degree, which is half, plus mu sin 30 degree, that is 0.2, into sin 60, which is 1.73, divided by 2 minus 2. So this value should come out to be some 5 into 1 plus 0.2 into 1.73, which would be some 0.346 minus 2. So this would come out to be some 5 into 1.346 minus 2. This would come out to be some 13.46 divided by 2, that would be 6.73, some value 6.7, or some 6.57 actually, 6.57 minus 2 meter per second square. So this would come out to be some 4.57 meter per second square. So this would be the acceleration of a block in the two cases when the force is applied at different angles. Same force 10 newtons is applied at first at the angle 30 degree and then at the angle 60 degree. So when the force is being applied at different angles, we get different values of accelerations. So let us do the last question. Question number 5. So a block of mass m is kept on an incline which is rough. Find the acceleration of the block if it is given that mu is less than tan theta. So the block is kept on an incline. The force acting on the block, or the gravitational force, that is mg, the normal force, that is normal reaction n, the force of friction acting on the block, that is F. So if we take the components of all these forces and assume that the acceleration is happening along the incline in downward direction, then we can easily guess that the downward forces are mg sin theta, that is the component of gravitational force in this direction, minus the force of friction should give us the acceleration of the block ma. And we know that the force of friction is given by mu times normal force, which would be equal to mg cos theta. And this component of gravitational force mg cos theta, this should be equal to nn, and this is equal to m into a, and they should give us the value of a equal to g sin theta minus mu cos theta. Now how would we know that this value is positive, right? So let us test it. So sin theta minus mu cos theta should be greater than 0. So that means sin theta should be greater than mu cos theta, or we would say that tan theta should be greater than 0, which is the condition given to us in the question. So definitely the block would move in a downward direction with an acceleration equal to this value. So this is what we have learned in this particular video, that is how to apply the force of friction in different cases, what assumptions are to be taken, and when they are to be taken, and how to draw the force of body diagrams of the blocks on which different forces are acting. So thank you for joining and have a nice day.